In a world of right triangles, one man stands alone. He will not wait. He will not hesitate until he discovers, based purely on the lengths of two sides, the length of the third side, the length of the hypotenuse. This man's name is Pythagoras, and today we prove his theorem, the theorem of Pythagoras. Beginning his journey, Pythagoras considers the existence of the infamous right triangle, a triangle consisting of precisely one 90-degree or right angle. We begin by labeling the lengths of our sides. Let us begin with the shortest side and call it A. The second shortest side, or the medium-sized side, we shall call B, and the longest side we shall call C. C is well known as it is the length of the hypotenuse. Now, as Pythagoras considers this right triangle, he wonders, in what way can I relate the sides of these triangles? And he thinks, yes, what if I was to draw an auxiliary? That would be, in this case, let us draw the altitude. So, Pythagoras decides, let us draw the altitude from the right angle to the hypotenuse. Knowing what we know about right triangles, we have now constructed what are known as three similar triangles. They are similar as they all contain this right angle, and the shared angle on this side and the shared angle on this side necessitates that all three angles of these three similar triangles are congruent. Bearing this in mind, let us now label our additional sides. Our hypotenuse has now been broken into two segments. Let us call the smaller of the segments X and the larger of the segments Y. And we can state very clearly on our paper that C must equal the sum of X plus Y. Bearing all this in mind, let us now see how we can relate the sides of our triangles. Let us begin by creating proportions. We see that in the sides of our original right triangle have all become the hypotenuse of a different right triangle. Let us begin with A, the shortest of all the hypotenuse. A would relate to the hypotenuse of the larger triangle. Now A is also the shorter side of the larger right triangle, and therefore the length A would correspond with the shortest side in the smallest triangle X. Using similar reasoning, we can say that B, the hypotenuse of the second triangle, corresponds with the length C, the hypotenuse of the total triangle. Now within the whole triangle, B is the second longest side, and so it would correspond within this triangle with the second longest side, which we see clearly is Y. Once we have these proportions, we now use our skills of algebraic deduction. Let us consider cross multiplication. Let us multiply A times A, which gives us A squared. Let me make that darker. And this must equal the product of C times X. Using identical reasoning, we can say B times B, or B squared, is equal to the product of C and Y. Now, having these facts, we can continue to use the addition property that we use so readily in algebra to say, if I were to add A squared and B squared, that must equal the sum of CX plus CY. Do you see where we are going? I do indeed. On the right side of this equation, we notice that we have what is known as a greatest common factor of c. Let us factor a c out from the right side of the equation. So we now have c times the quantity x plus y. Ah, my friends, let us return to our right triangle drawing. We saw that when we dropped the hypotenuse, the length c was divided into two segments, x and y, so that c is equal to the sum total of x and y. Returning to our algebraic equations, IC multiplied to c the x plus the y. Using the powers of substitution, I may now conclude that c must actually be multiplied by c. And in this universe and the next, c times c is most easily known as c squared. So a squared plus b squared equals c squared. It is done. The work of Pythagoras is complete. And with this theorem, Pythagoras solves yet another of life's grand mysteries, turning now to larger questions such as the meaning of motion, of change, of sameness, of difference, of knowledge, of existence, of metaphysics. But this question is better considered by the likes of Socrates, Plato, and Aristotle. This takes nothing away from our good man Pythagoras, for whom we will always remember as the author of the Pythagorean Theorem.